Good morning, students. I greet you all on the occasion of Ganesha Chaturthi and Swarnagauri festival. And this is my inauguratory session. I welcome you to my video lectures on network analysis. Network analysis is a vast subject and a very important core subject. And it is being studied by electrical student, electronics and communication students and instrumentation technology students, etc. So very important subjects, very important core subject. There are good number of books also on network analysis, but having taught the network analysis and over a decades, and I have the opinion that many of the students, they find this subject difficult, but it is not true, because they lack basics. They don't enjoy this subject. So being a student of technology and engineering, so a student must enjoy this subject, but they have a scare for this subject. I don't know why. So what I felt, they lack very much the basics. So having good in basics, they should not find this subject a difficult one. So that prompted me to take up video lectures on network analysis. So this is my inauguratory session, and for few days I will continue with the basics. Having completed the basics, then I will take up the topics in network analysis. Network analysis. So later I will define what is network analysis. Before going into the definition of network analysis, today I will go through some definitions of terms, branches. Students of network analysis or circuit analysis, whatever you call, they are supposed to be good in understanding these terms: branches, components, node. Node is also called as junction, principal node or junction. So today, in this session, I will go through these terms. So first I will take up components. So components, in electrical engineering we come across two types of components or two types of elements: active components and passive components. Active components, passive components. Components are of two types: active components and passive components. What are passive components? Passive components, they always absorb power. If they absorb power, they are called as passive components. For example, resistor. A resistor absorbs power, it gets heated up. That is why it is a passive component. Inductor is a passive component, because in inductor there might be some resistance. So because of resistance, in an inductor draws power. Inductance, resistance, inductance, capacitance. We don't find perfect inductor, perfect capacitor. They are all imperfect. Imperfect in the sense, a small amount of resistance present in inductor and capacitor. So these are called as passive components. What about active components? Active components, they not only absorb power, they also supply power. They are called as active components. For example, this is a source. This source, it can supply power. When it is supplying power, current comes out of positive terminal. So it is going to supply power. So in the charging mode, it can also absorb power. If it is absorbing power, then current flows in this direction, where it is absorbing power. Active components, they not only supply power, they also absorb power. this is a active component, and similarly you can have a current source. I will come to current source later. A current source is also an active component. So in networks we come across two types of components: active components and passive components. Now next we shall go to branches. Branches. So any network will have a set of branches. So you should know correctly how many branches are there, and the concept of branches are very important. Whenever the components are in the same branch, they allow same current. If two components are in the same branch, the current flowing through these two components is same. So that is what is called as branch. I will come to the counting of branches later. Now components, branches, components. Next, node. If two components are connected, then it forms what is known as a junction. A junction or a node. Now for example, this is resistor R1, resistor R2. If two components are connected, then it results in what is called as a junction. A junction is represented by a light dot. Light dot. A light dot. I will use light dot. Or every time I don't write light dot. So this is what is called as a node. Node means only two components. Two components are connected and it results in what is called as a junction or node. This is what is called as a node. It need not be resistor. Even an inductor and a capacitor, when they are connected like this, it results in what is called as a node. A node, for a node to happen, so two components are to be there. That is what is called as node. What about principal node? Principal node means, principal node or principal junction means three or more components. If three or more components are connected, then it results in what is known as a principal junction or principal node. For example, if we have one more resistor connected here, then the junction of these three resistors is to be represented by a thick dot. So principal junction, the condition is three or more components. So here 1, 2, 3. Three components are connected. It is no longer a node. It is principal node. It is principal node. Now this is also a principal node. This is also a principal node. Three or more elements, three or more components are connected. It results in what is known as a principal node or a principal junction. What I advise the students, so whenever they come across a principal junction, you mark it with a thick dot. So make it a practice to represent it by a thick dot. And in the next session, I will take up examples and I will ask you to count the number of branches and the junctions, principal junctions, etc. Thank you.